Okay, so let's start from 1D elements. So why we need this? So as I said before, the shape of the 1D element is a line. So we will use this to describe the behavior of members where the length is the governing dimension. For example, like for the long shafts, for the element of trusses, for the beams, columns, which can be subjected to many loads, for example, the tensile and bending forces, or even torque. So that's it, and then the next slide we can say a few things about rod element. So one of the listeners has got an audio problem. I think this is one particular case because no one is saying about this issue. So with full respect to you, sir, my recommendation is to check your audio. Okay, so we can continue. So let's start from the rods. So this type of element consists of two nodes, as it can be oriented anywhere in space, and it transmits force axially only, and there are 3 degrees of freedoms elements. They are, let's say, 3 degrees of freedoms elements, which allows translation and rotation around the element axis. So if you take a look on the picture, we can see local element coordinate systems for this element. So the x-axis is always oriented, let's say, with the element length, and rotational degree of freedom is around the local axis. So for the rods, as I said, we can transmit only tensile or compression or twist behaviors. For the next element, like bar element, this element also consists of two nodes, and it can be oriented anywhere in 3D space, but the main difference is that the number of degree of freedoms at the nodes is 6. So you can define 3 translations, and the node for the element consists of 3 translations and 3 rotations, and due to this, bending is, for example, supported. So if we take a look on this picture, we can see that the local coordinate system has got 3 axes, so tension, compressions, with or without bending, and twisting is supported. Sometimes offsets are provided, offsets, which means the neutral axis can be moved from the shear center. So this is the option what we have. And to the left you see some kind of input. So at this moment we will not talk about every kind of element, but let's say I'm starting from this one-dimensional elements just to refresh your knowledge from the previous webinar. So on the next slide you see the access dialog box for section. So Midas NFX has been equipped with a section template dialog box, and you can, from this dialog box, you can select required cross-section shape, for example I section, L section tube, and to calculate all required parameters you have to specify dimensions for selected shape. And please notice that every cross-section in the template has got information about the reference points like E, D, C, F. These are the reference points, and this is very important because depending on shape orientation it's possible to get different results than you expect. So for example, if you take a look on the below picture, Midas NFX calculates the results in these reference points, so you have to remember where are they located.